Hi everyone, today we're going to talk about overflow and rounding and what that means. So to start, we're going to explore large place values to see what happens when a big number gets too big. And to do this, one of the things that we're going to do is we're going to imagine working in a local store at a cash register, and in the cash register we're going to imagine that we have 9 $10 bills, 9 $1 bills, and 9 dimes. Okay, so assuming someone comes in and they buy something, I don't know, let's say they buy something for a nickel and they give you a $100 bill. What's the largest amount of change that you can give them back based on what it was that we just said you had? And the largest amount that you could give them is $99.90, even though you really owe them $99.95. Okay, so let's understand that we're limited by the amount of change that we have. Similarly, if we think about what's the least amount of change we could give, the least amount of change that we could give is 10 cents. And what would you do if someone needed 7 cents in change? And the answer to that is you can't give someone 7 cents in change. You also can't give someone $1.25 in change because you have no nickels. So you're limited by what is available to you in that cash register. And continuing along here, let me make sure I can go to this. Okay, so this is what your cash register looks like, and these are the questions that we just discussed. And overflow and rounding is going to introduce a Flippy Do template that looks a little bit different. So it's a Flippy Do, I think they're calling it a Flippy Do Pro. And we're going to have you guys work in groups of 2, and you can work in breakout rooms, and you will have probably broken out into breakout rooms. But if you missed class for some reason and you're watching this alone, that's fine too. Okay, so what we're going to do is we're going to start by exploring large place values to see what happens when a big number gets too big. And I want you to go to the binary odometer widget on level 2 of on Lesson Code Studio. So what you're going to do is you're going to go into code.org and go to Unit 1, Lesson 5, and then bubble number 2. And what you'll see is we call it a widget, and it's a widget that simulates a car odometer, which is a device on the car that tracks how far the car has driven, either in miles or kilometers. And you're going to look at the odometer. Now, your experience inside a car that might be more modern is that you're not actually seeing the odometer spinning. You're probably seeing a digital readout. But in older cars, there's an actual odometer that turns. And that odometer that you're looking at on the widget is similar to the odometer on an old-fashioned car. Okay. So I want you to just, navigate and play with this and just see how it works, and just, play around with it, become familiar with it. And what I want you to do then is, once you figure out how it works, I want you to set it to the highest number possible and then just let it run. Okay? So in doing that, one of the things that you're going to do is, once it runs, look at what happens. What happens to the odometer reading once it's at its highest and it runs? Does it still show the distance driven by the car? What you should see happening is you should see that it's going to flip from all the ones to zeros. And really, the way I want you to imagine this is, if you were in a car and the car had 5 place values, and you had just driven 99,999 miles, and then you drive 1 more mile, well, really you've just driven 100,000 miles, and there should be a sixth place value added to the left, but you can't do that on a physical device, right? That's it. You're stuck to the 5 place values. All those 9s are going to roll over and become zeros. It's not really that we're back at 0. You've driven that car 99,999 miles, and one more makes 100,000 miles, but you're just missing that one extra place value to add the 1 and then all the zeros. So when this happens, okay, and this is just kind of walking us through, when this happens, it's similar to an overflow. And this is what will happen when in binary we have an overflow issue. So what you're looking at right here is a Flippy Do Pro. And what you'll notice is the vertical line on the Flippy Do Pro. And you'll notice that we have to the right of 2 to the 0 power, we have 2 to the negative 1 and 2 to the negative 2. And for those of you who don't remember how that works, you're going to say, instead of multiplying 2 times the exponent, you're going to multiply 2 times the inverse of the exponent. So a half times a half would negative, 2 to the negative 1 would be 1 times a half, 1 over 2. And then 2 to the negative 2 would be 1, you could leave the 1 out, but that's always what you consider with exponents. 1 times a half times a half, and that brings you to a fourth, which also is written as 0.25. And I'm going to include a Khan Academy video reminding you of how to do negative exponents. But for now, just think of it as parts of a whole. What do you do when you're dealing with numbers that are not whole numbers? And that's what you do. I also am going to caution you that we're not going to call that a decimal point, because remember, deci means 10. Decimal points are really, it's a term that we really only use when we're dealing with base 10 numbers. So I don't want to use decimal point. I just want to use, when we're talking about numbers here, partial numbers. Okay? We could even say fractions. Okay, so moving along, and I will hope that you can cut out your Flippy Do. Okay, so challenge 1, and this will be done as the whole class together. You're going to produce the smallest binary number possible with the Flippy Do Pro. So the smallest binary number is what? It's going to always be the number farthest to the right. So you would have all zeros, and then your rightmost number would become a 1, and then you would say 1 times 0.25, and then your answer has a decimal value of 0.25. Okay? This is working it out, just as I had just said. Okay, challenge 2 is increase the number made in challenge 1 to the next possible value. Okay, so the next possible value is you make this a 0, you put a 1 here, and then what do we get? 0.5. Challenge 3, okay, make the values of 0.25 and 0.50 and 0.75, one after the other. How do you do that? So 0.25 looks like this, 0.5 looks like this, and then that equals a total of 0.75. Okay, so challenge 4, make all the fractional possible in binary using the Flippy Do Pro. Okay, you'll notice that there are no new values besides those made in challenge 3 because there are no place values for representing other fractions. If you might want to think about if you were to try and make 39 cents in binary, it can't be done with the values that we have available in the Flippy Do Pro. So it's kind of just like going back to the cash register where you only got dimes. You can't give change in pennies or in nickels because you only have dimes. It's the same idea. We move along. Okay, so this is exactly what we were saying. And challenge number 5, what is the largest number in decimal you can make with the Flippy Do Pro? And that would be if you flipped everything up, made everything a 1, and now what you're doing is you're saying 1 times 32 is 32, 1 times 16 is 16, 1 times 8 is 8, 4 times 1 is 4, 2 times 1 is 2, 1 times 1 is 1, 0.5 times 1 is 0.5, 0.25 times 1 is 25, and then you add them all up, and then you're getting 63.75. Okay? Challenge 6, I'm going to have you go into breakout rooms and work on together. Okay, so you're going to use a Flippy Do Pro, the one that we just had, to determine, and if you don't have the paper, just do it yourself on a piece of paper. Make it yourself. It's easy enough. Use a Flippy Do Pro to determine how much pie is left at the end of dessert. For each pie, make a decision how you want to round the number to fit on the Flippy Do Pro. Write this number down in the journal. And I'm going to let you work through these on your own, okay? With your group. So, pie, challenge 1, it's challenge 6, pie 1, you're going to work through this, pie 2, pie 3, pie 4, how much pie is left. Add all the decimal numbers up together, compare with a partner, and discuss, okay? And we'll talk about that as a class, okay? So, kind of in wrapping up, what does the binary odometer show about representing large numbers? What does the Flippy Do Pro show about representing very small numbers? And if we had a big enough odometer or Flippy Do Pro, could we represent every possible number? And so, in thinking about this, I think the idea is always go back to the idea of the cash register. You are limited by your place values. And those place values will create the situation that it is impossible to represent every number all the time. And so just to, in wrapping up, in our final challenge, you should note that your answer may be different than your classmates. It comes down to how you rounded. Did you decide to round up or down with the various amounts of pie? If we did not have to round, the answer would be exactly 1 pie left over. You may have come to the same conclusion by rounding or not. And so this addresses issues around rounding errors and, why you're not always going to get an exact number in computer science. And so, here we have fixed numbers, and think about the Flippy Do and the Flippy Do Pro. And an overflow error is what we addressed in the beginning of this lesson, and that's when trying to represent a number that's too large, right? The 99,999 miles that all of a sudden become 100,000 miles, and you can't do it because you don't have enough place values. And the round off error is when you're trying to represent a number that's too precise, and the value has to get rounded, okay? And that's really it. And just please look on the website, the Google site, for the Khan Academy lesson that addresses negative exponents. All right, thank you.